Hi, my name is Dan Burbank. I'm a crew member from Expedition 29, and I've been the commander of Expedition 30 since 5 days or 4 days, I guess, after we arrived in mid-November. And right now, I'm getting ready, as are my two Soyuz crewmates, Anton Shkaplerov and Anatoly Ivanishin, return back to Earth after more than 5 months living aboard this spectacular space station. And it's an interesting time right now to kind of take a few moments and think back at what we've done, what we've accomplished during the mission, and kind of take a little bit of a break from the hectic operations, just to reflect a little bit. And I think it's really important for me to kind of take stock of what we've done up here. It has been a whirlwind. It has been a head-spinning adventure, and it's been exciting and wonderful right from the get-go. Before I launched in this mission, I basically had three simple goals, and the first one was to take good care of the crew, and the second one was to take good care of the space station and all the hardware up here. And the third one was to conduct as much research, both scientific and technological, as the space station was capable and as our crew was able to do. And I think in reflection now that we've done a pretty good job of all three. And from the start, though, we had a couple of challenges, and I think one of the biggest ones was that we had a minimal overlap with Mike Fossum, Sergei Volkov, and Satoshi Furukawa. We had 4 days total with them to physically hand over, to learn the ropes about how to operate this spaceship. And that in itself would have been a major challenge if it were not for the fact that the ground and that crew were very clever and kind of thought outside the box. And we basically spent a couple of months leading up to our launch talking with them, getting video downlinks with them, and doing, I guess, what I'd call a virtual handover, learning all the ropes, learning how to operate all the intricate and critical hardware on space station, how to do even the mundane and routine things that we do on a daily basis. And it basically set Anton, Anatoly, and I up for success right from the get-go. And it was in some ways maybe better than having 2 months of overlap with the crew, because instead of getting a chance to see one thing one time while Mike and I had the chance to chat about it, I could basically at my own pace over the course of several weeks leading up to launch review a videotape that he had made of, say, a repair on one of our regenerative eclipse environmental control systems, for example. And so actually it was a very elegant and great way to get ready. Another challenge we had was that we had, Anton, Anatoly, and I, an extended period of 3 crew. Not quite as extended as Mike and Sergei and Satoshi had, but we still had a good 5 weeks plus with just the 3 of us knocking around this huge 360 feet wide, 240 foot long space station. And that also, if you're going to take the most advantage you can of the time that you got and do as much science, that's a challenge in anybody's book. Another thing we had is in the time leading up to our launch, the ground very wisely, and the crew that was on board very, very wisely and astutely, took the time to put the space station in a good posture if there were to have been a delay in our launch, such that we would have had no handover at all, such that space station would have been unmanned for a period of time. So a lot of preparations were made on all the systems across the space station to basically put it in a good posture so it could fly by itself under the guidance of all the folks on the ground without a crew to physically take care of things. So we had some time we needed to spend a lot of time to back out of a lot of those precautions and those system configurations that were done. The other challenge is, for me, a long duration mission. This was my first shot at that, and I'd flown twice on the space shuttle and knew how we operated on a shuttle for a 2-week mission, but that doesn't necessarily adequately reflect what it's like to be 6 months up here. And for Anton and Anatoly, this was their first space flight, so I looked at that kind of as a challenge for us. And probably lastly, and maybe most importantly, this is nearly a million-pound space station. It is unbelievably expansive, unbelievably complicated. and just anybody on a good day with an experienced crew operating all the things and being prepared if there were to be some sort of a serious malfunction, being prepared to deal with that, that was also a big challenge for us. On the plus side, the advantages we had is we were blessed. We had a wonderful crew, a great crew. We're all good friends, best of friends now, and very good friends before we launched. Anton, Anatoly, and I trained for a couple of years together, and Don Pettit and I have known each other for quite a long time. Andrei Kuipers from the Netherlands, and Oleg Kononenko. Now, those three are the crew members that came up in the Soyuz that joined us in late December. Everybody phenomenally talented, great personalities, get along wonderfully, and I think all of our strengths play very nicely against our respective weaknesses. So all in all, I couldn't have asked for a better team. Additionally, on the plus side, we have wonderful hardware. It amazes me when I sit and I look at this incredible space station and I think about all the time and effort and brain power that went in to anticipating all the possible things, all the connections between the various modules, between the various hardware, software connections, physical connections, and make it in such a way that it was robust enough to operate so well. And so that was a huge plus. And probably the biggest plus of all are the tens of thousands of people all around the world from the 16 partner nations that have built the space station. We have got at the leading edge of that, from our perspective as crew, we've got the control center in Houston, mission control. We have mission control in Moscow. We have the U.S. segment's lead science center in Huntsville. We have the Japanese Aerospace Exploration Agency Center in Tsukuba, Japan. And we have in Munich the European Space Agency's control center. These people are watching over this hardware, watching over us 24/7, 365. They're always there. In fact, a lot of what goes on in space station is conducted entirely remotely, led by them, but also remotely to all different places all around the world where science teams are running a lot of the experiments. And there's nothing more comforting than having all those smart folks watching out for you all the time. So we had a lot going for us as well. When I look at overall our accomplishments, I guess on the first count, the crew is healthy and strong. In fact, I guess we're in some ways maybe in better shape in some respects than before we launched. Everybody's doing really well, and everybody adapted phenomenally well to spaceflight and long-duration spaceflight. All of us love being here, and again, we're all great friends. And also on the accomplishment side, I would say the space station right now is in better shape than it's ever been. During our time here, we have done a major overhaul to the space station's brains and nervous system, if you will. So there have been 6 major software upgrades that affect all the major computers, and those involve command and control, guidance and navigation. They involve payloads and a whole host of other systems. And in addition to the software upgrades, there have been 23 major computer upgrades where we actually did brain surgery on these boxes, pulled them out of the racks where they dwell, and opened them up and changed out the cards that were already in there with faster, more capable ones. And we had a major software upgrade in the service modules control software in the Russian segment. There was also recently, just last week or 2 weeks ago, I guess now, a major upgrade for the Columbus, the European Space Agency software. So in addition to the software and brain surgery, if you will, there have been a lot of hardware repairs and improvements that we've made, and they run the gamut of almost every system we have up here. Part and parcel with the upgrade for the comm system and the computer system was laying new fiber optic and high rate communication cables that will allow us to have high bandwidth payload data, science data down the road, that allow us to have more communications channels that will basically increase greatly the throughput of science from space station. In addition to that, Russian segment EVA 30, the 30th EVA conducted by cosmonauts and U.S. crew members, when you look back on the Russian segment, was completed safely and successfully, and it relocated, Oleg and Anton relocated a very large crane, construction crane that we have on the outside of the station. They installed a couple of payloads, science payloads on the outside. We, in the Japanese module, demonstrated some very successful ground control, ground remote operation, teleoperation, if you will, of the Japanese experiment module remote manipulator system, the arm that controls or that's able to access all of the payloads that are on the exposed facility on the forward port side of Space Station. We had a lot of visiting vehicles. We had, when we got here, the 45 Progress number 45 was here. We safely saw it on its way, and it deployed a satellite, a first for Russian Progress vehicles. It deployed a satellite after leaving here, one that we placed there. We received Progress 46P. We recently, we also received 29 Soyuz with Don and Oleg and Andre. And then we just a couple of weeks ago received the ATV, the Automated Transfer Vehicle number 3, a European Space Agency contribution. So it's been a real busy time up here from the standpoint of visiting vehicle traffic. What we did not see, but we did help pave the way for, was we didn't see the arrival yet of Dragons, the Space Exploration Technologies, SpaceX Corporation's Dragon vehicle, the first commercial provided cargo ship to space station. What we did to pave the way for that, though, is we installed new software in their communications unit, the unit that basically allows the transmission of telemetry and command between space station and the Dragon. And we upgraded the software in there, and we actually took another box and we have a backup and a primary now for that, so we have redundancy in that respect. And we've done a lot of other preparations to kind of pave the way for Dragon, which will be coming in a couple of weeks. So on the visiting vehicle side, very busy. On the research side, which was my third goal, is we have done over 180 separate scientific and technological investigations during our time here on station. So it's been really busy, and those run the gamut from human research, which is one of the fundamental goals of the U.S. segment science, and that is how to figure out how humans adapt to spaceflight, how to figure out how to make it safer so that we can ultimately leave low Earth orbit, go to the moon, go to asteroids, and go to Mars, and do that in a safe way. A lot of changes happen, and they change. The changes occur in the physiology, basic physiology, musculoskeletal system, the vascular system. A lot of changes occur even in our perception, in our orientation systems, our perception of three-dimensional space and our orientation there. All these things are really important things to know if we're going to get crews beyond low Earth orbit, which is one of the fundamental goals of space station. In addition to that, there's basic biological research we've done. We have done fluid physics, including a wonderful Marangoni convection experiment that was conducted in the Kibo Japanese experiment module. Capillary flow experiments, combustion experiments, including an experiment called SPICE, or as we call it, SPLICE. And also recently a combustion of solids in space experiments called BASS. We have conducted a lot of Earth science. Here from Space Station we have managed, at least the crew handheld imagery, to take upwards of 200,000 images of planet Earth from here. And in addition to that, there are a lot of remote sensors around the space station that both image Earth and image deep space. And on the technological experiment side, or the technological development side, I think Space Station, because of its location on a frontier in probably one of the harshest environments known to man, is in and of itself a global, a very large technological research project. Figuring out how to keep hardware operating long-term here is absolutely crucial. It's crucial if we're ever going to leave low Earth orbit. We have to be able to safely sever the fairly regular logistic stream, the lifeblood that we have that allows us to get spare parts, that allows us to get consumables from planet Earth here. We have to figure out a way how to have crews be able to do all kinds of intricate repairs on Space Station. All the vehicles the U.S. has ever flown before have always been returned to the professionals or been returned to museums right after spaceflight. Crews have never had to turn wrenches to the degree that we have to on board Space Station right now. On the space shuttle, if there was a problem, you would basically get the system in a safe enough configuration so that the shuttle, when it returned to the Kennedy Space Center and was placed in the hands of the brilliant technicians and engineers there, could be rebuilt and be just as good as new. And we basically need to be able to do similar level repairs here on Space Station. It's a whole new way of operating for astronauts and for the ground crews that plan how we do things. So on the global scale, this is a really important thing, and I think we've had a chance to turn a lot of wrenches and do a lot of work along those lines. There's also a couple of other smaller experiments here that I think are important along those same lines for technological research. And one is Robonaut, which is basically a human-like, from an anthropometric standpoint, robot that is a technology test bed to figure out how we can incorporate robotics here in space to reduce the risk, to maybe capitalize on the crew time a little bit more by giving more mundane and routine kinds of tasks to robotics, but also potentially down the road we'd like to think to be able to take robots like that outside with us during spacewalks. And by having hands that are just like human hands, that Robonaut can, in effect, operate with all the tools that we operate. And so it is a very clever, very intricate, very complicated, but very promising kind of technological research. We actually put him to work last month, and he was taking readings on an instrument called the VelociCalc, and basically reading the velocity out of intermodule ventilation ducts, and it was a very neat thing to see. Probably one of the most important technological research things that we have going on board Space Station is the regenerative environmental control life support system. So the racks that make up the capability for us to close the life support loop, or at least partially close that, are critical for exploring deep space. Every pound of stuff that we bring to space right now to low Earth orbit takes 20 to 25 pounds of rocket fuel and rocket body to get it up here. That's how much kinetic energy you have to put into it to get here. It means that every pound of me, every pound of air that I breathe, of food that I eat, every pound of scientific experiment payload that we install and work on in a rack here takes 20-fold times more in rocket fuel to get here. So what we want to do is basically capture all the moisture that we exhale, all the moisture through urination that we get rid of, and take that and purify that water and feed that water back into the front end of the environmental control system loop, so it doesn't cost all that much money. And that technology also is very promising down the road for allowing you to deal with disasters in areas where suddenly you don't have water available. It allows you to purify water and do it in a very cost-effective way. So that whole piece of Space Station doesn't fall under the rubric of what we call science investigation, but it's a very important technological research investigation. And we have spent a lot of time in those racks and spent a lot of time keeping that equipment working, and in so doing have learned a lot about how that gear works, how to make it better for applications on Earth, how to make it better for applications leaving low Earth orbit. So all in all, when I look back on my tenure here and thinking about returning home, I think all of us can feel really good about the amount of things we got done. And again, I cannot overemphasize how much and how critical it is, all the people that work on the ground that make all of this possible. And we're just one small part of that equation. Now, when I sit down and think for a moment about returning to planet Earth, part of me is really going to miss this. It's indescribably wonderful to live in space, to have the incredible privilege of being up here, to do the research we do, to just float around, to look out the window and see planet Earth below and the stars above us. And but by the same token, it'll be so wonderful to see family again. You get to see your family once a week. You get to talk to them on the phone every time you get a chance, maybe once or twice a day even. But it's not the same as being there. So leaving this place will be hard. Seeing my family again will be the most wonderful consolation prize you can imagine. Smelling the aromas of planet Earth, landing in the Kazakh steppe on our Soyuz, and just climbing out of the hatch and feeling fresh air on our face will be wonderful. The food that we have up here is great. There's a lot of food that I can't have up here that I would very much like to have. That'll also be a good consolation prize. The ride itself, leaving space station and re-entering Earth's atmosphere in a capsule, will be pretty spectacular by all accounts. Having done it a couple of times in a shuttle, I really look forward to the experience to see what it's like riding a Soyuz back to planet Earth. So it'll be a little bit sharper deceleration, particularly at the very bottom. But I think it'll be an awful lot of fun. If the ride uphill was any indication, it'll be a tremendous amount of fun. And at the end of all of that, I get to go home and I get to be with my family.